Welcome to Bada's video lecture. In this lecture, I'll introduce you to the I/O namespace. I'm going to explain the different mechanisms provided for storing data into the persistent storage, such as the file system, the registry, and databases. Along with this, I'll also discuss serial port communications, as well as inter-application communication mechanisms. The I/O namespace contains classes for reading, writing data from and to the persistent storage area, file, database, and registry of the device. This also facilitates the serial communication functionality with external compatible devices. From bada 2.0 onwards, multiprocessing of bada applications is supported, and inter-application communications is facilitated through channels. First, let's briefly look at the bada file system. Files and directories are the basic entities of the bada file system. Each entity's storage space and properties, attributes, are allocated and managed by the file system. I'll be explaining the details of these entities in the coming slides. In order to secure the data files, every bada application is assigned a private storage area in the device file system when it's installed, along with enforced accessibility restrictions. I'll discuss these restrictions as well. Like any other file system, a directory folder is a virtual container in which groups of files and other directories can be kept and organized. Directories can be created under another directory and can form a directory hierarchy. Each entity in the directory hierarchy is accessed, addressed, through a unique and absolute virtual path. Mapping between virtual paths and physical paths is managed internally by the system and the platform. The current application or working directory is not supported, so relative paths are also not supported in bada. In the path name, directories are separated by the slash delimiter. Directory file names are case sensitive, so while accessing them, proper care should be taken. The directory class facilitates basic functionalities, such as creating, deleting, and renaming directories. It also facilitates the traversal of all the directories under a selected directory. Handling files and directories needs proper resource management, which is quite costly from a handheld device perspective. So bada imposes a limit on the maximum number of file or directory handles that can be opened simultaneously. The maximum number of directory handles is 30. A file can be described as a collection of non-volatile data or information and remains available for programs to use after the current program has finished or even after the power goes off. Like directories, file names are also case sensitive. The maximum number of opened file and database file handles is limited to 150. File APIs facilitate basic file operations, such as file open, file read, file write, file creation, file copy, file move, file remove, etc. operations. For extra security, it allows you to create encrypted plain files, along with the conversion mechanism from secure to non-secure and vice versa. Files are accessed through system-defined virtual path prefixes. Access controls and file permissions are pre-configured by the platform itself and can't be modified. Applications have the right access only for selected directories, so proper attention should be paid to code that requires the right access. A detailed list of accessible paths and permissions is provided in the coming slides. The /home directory represents the primary home directory of an application, and both the read/write operation can be performed on it. Share and share2 are two special-purpose subdirectories under the primary home directory for sharing data with other applications. Data files under the Share folder are created and managed by the host application and cannot be modified by other applications. The host application can access this directory with the /home/share path name prefix. The share2 directory is meant for sharing data with trusted applications only and can be managed by both the host and trusted applications. The host application can access this directory with the /home/share2 path name prefix. The /home ext directory represents the secondary home directory for bada applications. In order to use this directory, the system must support external storage cards, and the memory card should be present. Private data in this directory should be stored in encrypted form to ensure data security. In order to access other application data files, the application ID must be known beforehand. Applications can access the directories shared by other application with the /share/app ID or /share2/app ID path prefix. The /res directory holds all the application resource files, such as the icons, images, sound files, etc. Applications have read-only access to all the files under this directory. System media files, such as images, sound, and video files, are kept in media directories, prefixed with /media/ and /or /storage card/ media/. The prefix /storage card/ media/ represents the media folder on the external memory card. The I/O namespace only has the read-only access to these folders, whereas the media and content namespaces have read and write access to these folders. This example traverses through the list of files and directories under a directory by using the directory class. Let's see how we can use the directory and dir enumerator API for this. In line 5, we open the directory handle of the /home/test/ directory through the construct method. In line 8, the readN method returns a directory enumerator. In lines 9 and 10, we traverse through the files and directories under the test directory inside a loop using the enumerator. This example shows how to manipulate directories and files by using the static functions in the directory and file classes. To create a new directory, you can use the create function provided by the directory class. By passing the directory path to the create function, you can create a new directory. You can also rename a directory using the rename function of the directory class. You can delete a directory using the remove function. Besides these functions, the static functions of the file class, such as copy, move, remove, and get file extension functions, are provided. This example reads and writes data to a file using the file class. First, when constructing the file, we specify the absolute path to the file. Here, the absolute path is the virtual path provided by the system. After opening a file, you can read or write data to the file using the read and write functions. At this time, you can use the character array, string, or byte buffer as the buffer to get data. In addition, a seek function is provided so that you can move the pointer to any position in the file as with the fseek function. The file class provides the tell function that returns the current position of the pointer. Next, I'm going to explain the registry class. The registry is generally used to save application settings or configuration data. For enhanced security, bada facilitates both secured or non-secured variants for creating registry items. Registry files can have several sections, and each section can have several entries, but only to a single depth. Each entry refers to a name-value pair, and the name should be unique inside the same section. There are certain limitations, restrictions imposed on registry operations. A section or entry name should not include the characters WO, WN, pound, and equals, and the entry value should not include WO and WN. There's no limitation to the number of sections and entries, so there can be many sections and entries inside a registry. Again, there is no limit to the length of a section name, entry name, and entry value. However, developers need to take care of the data types being used, as these support only int, double, float, string, UUID, and byte buffer. Let me show you how to use the registry. First, to use the registry, you have to specify the reg name as a string variable. The reg name is /home/reg test.ini. Section 1 has been set as the section name, and S1 key 1 has been set as the key name. Then construct the registry giving the registry name. Then you can read the registry. After that, you can add a section with a desired name to the registry by using the add section function of the registry. To add a key value pair to a section of the registry, call the add value function, giving the section name, the key name, and the value. To read the added value, call the get value function that returns ival, which contains the value. Database is a very common term, and it's well known for its efficient data management. So I'll only talk about what bada provides with respect to database functionalities. Now, let's have a look at the database class. The database is thread safe by using a mutex and supports a subset of SQLite compatible commands. Bada supports creating secured and non-secured variants of databases and an interconversion function between these variants. You can use the Bada database as follows. Construct the database with the database name and execute an SQL command to create a table. Then create an SQL statement. Bind the data necessary for the state, and execute the SQL statement to add a new entry to the database table. Let's see how we can use the database with an example. First, you have to create a database. Construct the database class with the database name. Then you can get the database. At this time, since there's no table, you have to execute the SQL command to create a new table. The table has an integer value in column 0, a double value in column 1, and a text string in column 2. Let's have a look at an example to add a row to this table. First, to acquire the mutex of the database, you have to execute the begin transaction command for the database and construct the statement to insert a data row. Bind the data to this statement and execute the statement. Then the database is ready for the row insertion. Finally, you can complete the transaction using the commit transaction function. This example shows us how to update the database contents. To update the data, start the transaction and execute the SQL command to update the data in the table. This example deletes a row. A SQL command to delete a row from the table has been executed. You can also delete the entire database. This example searches for a specific row in the database. Construct the database, giving the database name, and create the statement to search for data. Bind the keyword string to be searched for and execute the statement. Then you get an enumerator. You can get the number of found columns by calling the getColumnCount function of the enumerator, and get the data using the getStringAt function. In the next few slides, I'm going to explain the serial port communication feature of bada. A serial port is a physical serial communications interface. The serial port class encapsulates low-level serial communications. Before starting serial communication, the host device needs to first activate the serial communications feature on the device with the @ plus OSP serial open command. The serial communications feature is deactivated when the user disconnects from the USB cable. From an application point of view, the construct method is used to open the serial port. All the read-write operations from to the serial port need to be performed only after the port is opened. However, there is no close method to close opened serial port instances. The only way to close the open serial port is by invoking the destructor of this class. Therefore, if the serial port class was initiated as a local variable, it won't be closed when it goes out of scope. For transferring data from the bada device to the host device buffer, the write API is provided. For receiving data from the host device application, you need to register one serial port event listener. The interface iSerialPortEventListener provides the event handler routine on serial port data received N with received data and errors through the on serial port error occurred callback. In lines 3 to 9, we prepare the byte buffer with the data to be written to the serial port. In line 12, we're making the myClass instance as the serial port event listener for handling the receipt of data or error occurrences. In line 14, we are writing the buffer data to the serial port. In the coming slides, I'll explain inter-application communications, or IAC, and channels. From bada 2.0 onwards, multiprocessing of bada applications is allowed. In the multiprocessing environment, communication between different applications, processes, is essential. IAC is a mechanism to exchange information between two applications or can be used as a trigger to make something happen. In bada, inter-application communication is achieved through channels. The IAC example shows communications between the SMS application and the contact application. For sending an SMS message, the SMS application needs the phone number. So I send a request to the contact application. On receiving the request, the contact application searches for the phone number and sends the result to the SMS application. After getting the result, the SMS application sends the SMS. An application can communicate with another application using a channel. A channel enables an application to send, receive data to or from another application independent of the underlying IPC mechanism. There are two types of channels. One is a client channel, and the other is a server channel. The client channel is used to send a request and receive a response from the server application. The server channel is used to receive a request and provide a response to the client application. Okay, let's see how we can use the client channel through an example. In this example, the client application requests the server application for a list of online friends. In line 5, the static method client channel get instance returns the default client channel instance. With the set channel response event listener API, we're making the my app class instance as the response event listener. In line 9, we're defining the callback method on channel response received N to process the response result. In lines 12 and 13, we are simply displaying the response from the server application. This code snippet shows how to use the send request API. In lines 5 to 10, we're creating the argument list that will be passed to the server application. In line 11, the static method client channel get instance returns the default client channel instance. The send request API sends the service request to the server application with app ID 123456789 along with the message in the argument list. This also assigns a unique request ID for the current request. In the case of multiple requests and responses, this request ID is useful to identify the response corresponding to a particular request. This is the server application implementation for handling client requests. In line 4, the static method server channel get instance returns the default server channel instance. The set channel request event listener API is making the my server class instance as the request event listener. In line 7, we're defining the callback method on channel request received N to process the client requests. In line 10, it's retrieving the list of online friends. In line 12, it's sending the online friends list to the client application through the send response API. Let's sum up this lecture. Using bada's I/O namespace, you can read, write, from, to files, databases, and the registry. File APIs can only write to the /home/home ext directory. Bada uses the SQLite database engine and supports a subset of SQLite features. Serial communication with connected device is realized through serial port APIs. There is no close method to close the open serial port or file handle. Channels facilitates inter-application communication.